Today I want to give you an update on the, let's say, the latest developments, the latest activities that we have been developing. And just to remind you, we are operating in offshore renewable energies. This includes offshore wind, wave and tidal. Probably around 80% of our activities are concentrated in offshore wind because of the size of the market, I would say. But of course we have very relevant activities going on also in the related to tidal and a little bit less related to wave as well. No? Okay, so as a summary, there have been a number of activities. So we have been focusing on one hand is international activities as well. So we have some very, very relevant new research facilities, a new research facility, a new research asset, I would say. We have a number of new R&D projects that have been recently approved. We have been also working with universities with a good level of activity, increasing activity, new activities. We have some new partnerships with relevant industry stakeholders, and we have new products that we have developed as a result of the R&D activities that we are developing together with universities. So we have been successful in commercializing 2 new products as well. So this more or less, I think, reflects the range of activities we are doing in the offshore renewable energy catapult. We are doing some other things as well, joint industry programs. There is a lot of testing activities. I'm not going to focus there because these are closer, let's say, to R&D. I mean, R&D activities, and these activities here involve relationships with universities. In some cases, SuperGen universities in particular. So I'm following the steps of Henry and trying to, I will never catch up because you are really influential. And honestly, I think this is really important because what SuperGen is doing, especially in the European domain, also internationally through the IEA, is very relevant. There is a lot of influence. The UK is clearly seen as the leading country in marine technologies, and this is because of the outstanding achievements of the academic sector, also industry. There are lots of things going on here, but it's also because there are key stakeholders very active in the European domain, like Henry in particular. So in the wind sector, I was selected the chairman of the IEA EXCO Executive Committee, which is the equivalent to what Henry has been presented by in the wind sector, which is also an interesting environment because it gives an overview of what is going on, what is the research agenda internationally. It includes countries like China and Japan, the US as well, so, and it's very rare and difficult to get access to information what is going on in these countries, so the IEA is very interesting for these kind of things. Definitely our main milestone, it is a new research asset that we have, so we have been extremely lucky, I have to say, because we have had access to a 7 megawatt research wind turbine which is operating in Scotland, is in Leavenmouth area, and this is not only the research wind turbine itself that we are now operating effectively ourselves. It is that we have had access also to all the design information, all the IP. This was developed by Samsung. Samsung decided to stop the activities in the offshore wind sector, and it was the opportunity for us to acquire all that, including the knowledge. They have invested a very significant amount of money. And this is a very unique asset. No other research organization is having this kind of facility. There are other research wind turbines operating there in the world, but no one is having that size, which is the latest technology, plus the IP and the design information. And our plan is to have this as a kind of open access facility for academia and industry to really demonstrate new technology and for example, verification of design models, demonstration of condition monitoring technology, sensors, etc. It's so wide, the range of activities. Some of the activities are also potentially relevant for the marine sector. So condition monitoring in power electronics, which is one of the activities we are already doing, could be also relevant, for example, for the marine sector and some other activities as well. So this is also a kind of an invitation to really think about ideas. We are already coordinating these activities through SuperGen Wind, but definitely through Robin, we will be also identifying potential opportunities for the marine sector in the context of this facility. Okay? And we are already discussing with our European colleagues in the European Energy Research Alliance as well, but the wind side, on potential activities. And there is one project on control, which is potentially, if we are successful in that proposal, will involve this wind turbine as well. We have been also successful in winning Horizon 2020 projects. At the moment we have 6. We have been notified today of another one. So we have 6 Horizon 2020 projects. Some of them are in contract negotiation. 2 of them are relevant for the marine sector. I will give a little bit more detail later. And the other ones are relevant for the wind sector. So the active portfolio we have now, it is like £3.5 million in active projects, which is good. In terms of academic engagement, we have started sponsoring 5 new PhDs involving these universities. This is on top of the 2 ID core students that we are also sponsoring. We are really proud and happy. There are outstanding results coming from the ID core program. So, and these are really useful results for us to really develop competitive advantages in testing and some other activities we are doing. So this is definitely an outstanding program. And I think it is also worth mentioning the industrial R&D partnerships. Well, we have now we have signed an R&D agreement with EDF, and we are developing some R&D activities with them, and some heavy industries as well. So we have just started. This is of course connected to the 7 megawatt research wind turbine. In the case of EDF, it's connected to an experimental offshore wind farm that is going to be built in Blyth in front of our facilities. And the new products commercialized. Well, I think this is a very good example of collaboration with universities. In this case, this is a focus on wind energy, but I think it illustrates very well how the collaboration with academia can really produce outstanding results as well. So it all started 5-6 years ago with a PhD with Durham University. So we wanted to accelerate the testing time for blades for the wind sector. It takes really long, several months, and it's expensive. So how can we accelerate that? Having a better representation of the operational conditions of the blades. Well, we started with a PhD with Durham University. It was followed by a KTP project. Now we have started a patent process. We've got the DNB accreditation of the software that has been developed, and we have a project with a commercial partner, LM, which is the main blade manufacturer in the world. So they are really interested in this methodology. So this is, I think, is a good case study. We have a bearing test, which is a new product. So we are testing bearings for wind turbines. In this case, it was, but this is going to be applicable also for the marine sector as well. And well, we have developed commercially also an anti-icing solution for wind blades. I'm not going to go into details, but these are active projects that we have in our pipeline, which are related to marine energy at the moment. So we're including things like tidal blade collision, biofouling. There are elements of testing here. EU FP7 project also focus on testing with different technologies, reliability, and some other components, cable connectors, umbilical monitoring cables, etc. So it's a wide range of activities. This is just a picture. We are really proud about this new asset, as I mentioned previously. This is the 7 megawatt research facility. These are the longest blades in the world at the moment, so it's really top technology. So it's an offshore, but it's really funny. There's a bridge here, so it's 10 meters offshore, but it's offshore. So there are a number of things you can still do there underwater, corrosion, things like that can be done in this place as well. So interesting, and well, a little bit more detail about this. But again, I'm convinced that there will be a number of activities that we can develop in the context of this research wind turbine that will be applicable and relevant for the marine sector as well, for the tidal, mainly tidal sector as well. So, and then as a complement, which is also a very unique thing, we have the same nacelle. We have another one. Oops, sorry. You cannot see it very well, but this is the same nacelle which is mounted in the operational wind turbine. We have another copy in our drivetrain test facility. So we can really, the idea is to measure the operational conditions, the loading, the forces that the wind turbine is experiencing in the field while it is operating, and then reproduce those conditions in our test rig, the 15 megawatt test rig that we have with the same nacelle. So you can really check if the test rig is able to reproduce the same operational conditions, and so this gives us more or less the level of uncertainty that we have when we are using our test rig here. which is another good opportunity. Just to give you an idea of the initial activities we want to do, the first thing is to instrument it as much as possible, the operational wind turbine. And of course, the second thing is to simulate it as much as possible, so to develop models from the component to the full system scale. And then we are discussing with companies like, well, the ones that develop the control, so they want to check if the design assumptions are real, so they will, of course, they are really interested in getting the real data to cross-check all the design assumptions, the design tools, etc. So, well, I think that's it. It's just an overview of the activities. Okay, thank you.
This production is brought to you by the University of Edinburgh.